Okay, so in today's session, I might not be coding it that much. I wanna make sure that I understand how to approach this to-do here, which I am not really certain of in terms of what to do there, right? Let me see if I can open again the drawing thing that I had. Is it this one? There you go. So we've got these, right? Now, the way this works in theory, right, is, or, I mean, not in theory, but really it is the way that it's supposed to work, is if, or the way that I implement it, is that if you go to, let's try to see what happens here. So we have two hardware gates, right? Correct? I think that's not correct, by the way. That is definitely not correct. That is definitely not correct. What the? That was these all the time, so just apply hardmart to Q0. Why did this even work? Well, because I think it actually leads to a similar set of branches. It's just that they... we'll see now. Anyway, so the point is, those get split, right? But like you have, so after this happens, you have these four. Like that's the way the operation works right now, right? Like you get up to this point, you do the 2-qubit operation, and then you take the four amplitudes and turn them into branches, and then try to merge the branches. That's kind of the generic way to apply this. Like, yeah, we have the other operation where we have the other implementation of the controlled gates where we manually split this node. What have we got here? There's no printing or anything. Why isn't this printing? Why isn't this printing anything? There's definitely something wrong here. There's definitely something wrong here. Okay, but it's fine. It's not the point. I'll fix that later. I'm trying to think what to do with the amplitudes, right? Because the idea is, if you go to the code, so we take these probabilities. So we are doing the gate. So we apply the gate. That's this instruction here, this line here, and then we're creating for each of the elements of the new state vector, we are checking, if the probability is greater than 0, right? We create the branch 0, 0, 0, 1, 1, 0, 1, because that's like sort of our base, right? So those are our base states exactly. So we create the node, we create the two nodes, and then we add them to the proper branches. So we have the nodes and the branches, and we add the I call this amplitude. It's just because this really is the amplitude of the, like if the edge represents, uh, a portion of your overall system wave function, that's the amplitude. The way that we interpret these edges, right, are that the system is a sum of all the edges, of all the entanglement edges, of the systems that that each entanglement edge represents. So I think it's correct. I think it's okay to call it amplitude. But then as we merge, what happens with these, right? Like we have the merging here where we just say, are they mergeable? Are they mergeable, right? And if so, then merge the edges. Which basically what we do is we iterate over each, like over all the pairs of nodes, and if the qubits are the same, then we sum the states and we normalize the state, and then we have the new state here. And then we create a node and we add the element. And so we have the new edge, right? But this new edge doesn't have, like, I gave it an amplitude of 0. Now the question is, I need a good enough example to figure out what this can be, right? Because in this case, that's a bad example, because in this case there's no merging happening, right? Where's the case where there is some merging happening? I mean, isn't there merging happening here? At least in this implementation, if I do not merge these, what do I get? Let's take a look. So if I do not merge these, if I do not merge the branches, right? What do I get? So I get these, which is basically the 2 qubit edges, and then the 2 entanglement edges between the nodes 0, 0 and 1, 1. That's correct. Okay, so I already get that. So that's not useful. That's definitely not useful. I'm trying to think about a case where I would need a merge. I mean, I could also just implement a from state vector function. What could be a case where we need these things to merge? So if we apply the Hadamard gate, because it seems like I thought, maybe I made a mistake. I thought that by virtue of the fact that we were applying the 2 qubit gate matrices, we would actually get sometimes things that need to be compressed right away. But it seems like that it was a mistake, because I had like 2 Hadamards in here, and that might have just been a mistake in this case, right? Because, well, it was a mistake. The fact you get 4 branches, that I was getting 4 branches. But nevertheless, Okay, what if I do another control NOT gate now? Well, the problem is I haven't implemented that, I think. But if I would assume if I do another control NOT gate, right, what this would do is it would take I don't think that's gonna work. But I would assume it would take this and turn node 16 into a 0. And then it's when merging needs to happen. So we can take that as an example, but I think, as I'm seeing now, I think that I might have um, to adapt because I don't think this works, but we can try. So if we now apply another gate, exactly the same, okay, what do we get? An error. Nodes. Remove node. Clean up original nodes. Okay. So what is happening here in the second iteration? Because I think that was definitely something implemented in this one. Like if I use these, it would probably work well. Here I'm getting the nodes of the two qubit edges. These nodes yeah, that was a to the left actually here. I think that the problem here is that if these two qubits are in entanglement edges, I should not, so I should kind of apply these operation to the subsystems, to each of the edges separately. I think that's what I should do. That's the way this works. Either I give it the system, or I give it the edge, right? You know what I mean? The logic of these would be that I apply. Those are the hardest parts of the whole thing. But I would assume that here I need to go through each entanglement edge and apply that gate to each of the edges. Now the question is, can I have, think if the two qubits are already in branches, like if the two qubits are already in, what if they're not? What if there's a third qubit? Oh man, that becomes complicated. So if I have something like that, the way that this should work is I go through each entanglement edge and I treat each of those as a separate system. And I apply the gate to that system. Now this might lead into more edges, or just a change in the edges, right? Probably more edges. How would I do that? Now this is one case, and the next case would be, what if one of those elements is in an edge and the other one is not? For example, what if we have a third qubit? I think I'm going to leave that case. So we have a third qubit, and then, we now have this system, and we have a third qubit, and then we now say, hey, third qubit, do a C naught with Q0, right? Oh, it's complicated. I think I'll have to, in this case, I don't know. In this case, I really don't know how I should process these, but I think that is the thing is, this function works for a particular system, right? How could I generalize that so I can give it a subsystem actually, not just a system? Maybe if we just give it the nodes. Because what do we use system for? So we used to add the nodes, but these can be but this is fine. I think this usage of system we can keep it. I think the trick here is to give it the nodes the operation is supposed to be applied to. I think if I so if I basically system qubit 0, qubit 1, what is this used for? Yeah, it's used for this kind of stuff in here. It's between these qubits, but we give it just a subset of the nodes. So we tell the guy to just say Q0 nodes. So I know I kind of don't like it a lot, but look, we're experimenting. So just give it the nodes. And now this gate is applied down here, so I need to give it the nodes, which basically is so right before the operation we would do these, right? And say, hey, you have control nodes, target nodes. I think I'll do it like these, Q0 and Q1. So I'll call it control nodes. Control nodes and target nodes. So Q0 and Q1. It's a bit redundant though that I'm using the keys for the edges here, right? I probably don't have to. I probably don't have to if it just, yeah, I think I don't have to actually. I can move these things here because I can read that from the nodes. Like I'm assuming they're all from the same. I'm assuming they are from the same qubit, so I can just do like these control nodes and target nodes, right? And then what I do is I just get these guys here, and I can take these properties from the nodes. I'm assuming they're not empty. I'm assuming they all share, you know. I'll do that later, but I'm saying like the nodes not empty and from same qubit, blah blah blah, etc. Right? So qubit 0 is really qubit 0 is really just saying Q0 nodes, say the first, then qubit, right? And for qubit 1, it's this. Qubit 1, 0, 0 qubit. I think that should do it. So I just pre-select the nodes. Okay, I should just give it the nodes. So by doing this, I have the freedom to say I want to apply this to these ones, and now I will say oh, I have to add another wrapper on top of that, right? Because that's not what you wanna. Like, you shouldn't know about these, right? You definitely shouldn't know about this level. You should say, what you should say is, like, apply to qubit gate. So this will so this will probably should be applied to qubit gate 2 nodes, because definitely you don't want to have, like, that's you want to be able to say I want to apply this to qubit gate to these two, between these two qubits. So the signature, you want to keep it, but then you want to be able to say, if I have the entanglement branches thing, then just pre-select this a bunch of nodes instead of just doing all of them. So this is not there finished yet, but I'll just assume I'll do that. I'll fix that next time, because this is going to be a short video. But here, what we want to do now is we want to say, well, we want to apply these to each of the edges, right? So what we want to do is we want to do, let's try. Let's try to do this by hand and say control nodes are the nodes of get how I would do these. I would have to select the nodes that are that's complicated. I would have to say, what I would need to do is I need to do so I need to get the edge that I want. I need to get the elements from the edge, right? So elements from the edge. I need to go system edges. We'll just iterate over edges. For edge in system. Can I just, like, system edges? System edges. Do this is E, and I'll say edge. System edges E. So now I have the edge. Now what I want to do is I want to say I want to have the control nodes and target nodes being empty lists. And I want to say for, this is definitely overdone, but like for n in edge elements, node equals edge elements n. And that's like if node dot qubit equals q0, then then control nodes equals np append control nodes, the node. Else, and again, I'm just hard coding this now to try whether it works, okay? Target nodes equals np append target nodes node. What I'm trying to do is in classifying where the control goes and all that stuff, and so and the target goes, right? Because I have to find them within the edge. And once I'm done, now I can apply. And this kind of happens for each edge, right? Which is okay. So now this is not something, as I said, like you would usually do here. Like this is some logic you would encapsulate into the bigger, like the more generic apply 2 qubit gate. So you would check, are those 2 qubits in hyper edges? Yes, then we should, you know, go this way. If not, then we just give it all the elements. I should have a better way to query for these elements, which I would if the memberships will work, which I think it works. I got an email that I think they fixed it, so I might just want to update my library and then try. But first of all, does this work at all if I just like comment this for now and this, and so we have first, does this work at all? Key error 0. Can I just cast it to a list? What if I do list? Because I really don't care about the symmetric qubit. String is symmetric qubit. What? It's getting the Can I just I think I can get like Python get list of dict values. I think I can just get a list of the values of the dictionary at that point. List the values. Okay. The values. So if I just, because that is a not an entity. List indices must be integers or slices, not entity. Exactly, I just want these. What if I print? What if I print? So let's elements. So the print is right. This is a dictionary and it's a node. And then if I print values, it's no attribute values. List object. It's already a list. It's not. Get entanglement. Can I just change these so yeah, it's at least. It should be at least append result append edge. Maybe I should just say result equals np. Oh, wait a second. These are the edges, right? These are the edges. I think I'm doing something wrong. These are the edges. Da, 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 da. What am I doing? So this is one edge and I'm getting the elements. Sorry. And the elements, yeah. That's not like... Oh, it's complaining about this one here. Sorry. What is these? What? Did I just add these now here? I hope. I hope I didn't just add these now here, but this is what I'm trying to do. Print these. And now, I think I just added that accidentally. Values. Values, exactly. So if I just cast this like that, yeah, that should work. So if I just, yeah, I think it was just working. I think I just put it in the wrong place. That's why it's complaining. But if I just take these, and this is for Q1, I do nothing else. Let's see what happens now. List instances must be integers, unless it's not entities. Oh, because now I've given it eh, that's fine then. I don't need that. If this is already what I need. What was the problem? Oh, the problem is here, is that I cannot. I'm stupid. So, Python get first element of dictionary. I think just with keys and something like that. Yeah, I can just probably use keys and then select. And Python 3. What did I miss that? Here. Non-destructively. Next, iterable my dictionary values. Okay, so I can just use that. Apply to qubit gates. So this is Q0 nodes. This is Q1 nodes. Hopefully that works now. Yeah, that works. Okay, it seems like it's applied that correctly. 0, 0, 1, 1. That's good. I'm gonna call these apply to cubic gate. I don't know what name to call it, but like multi-cubic gate to cubic gate. Doesn't matter. Okay, so that works like these. If it's dictionary. What if it's not a dictionary? Because now in here I'm gonna mess up. I'm gonna say, okay, now this works. So if I now go here, the problem is that it's not gonna. Okay, so instead of appending, what I should just say is control nodes. So what I should just say is n equals node, and I think that should do. That builds a dictionary, and then we keep the. We don't have to touch the implementation. So I iterate over the elements iterate over the edges. Then iterate over the nodes of the edges. And if the qubit is 0, it goes to control. If not, it goes to target. And so once I'm done collecting these for one edge, I apply the operation within that edge. Exactly. I don't think that's going to work out, to be honest. Okay. List indices must be integers unless it's not strings. It's because I've created that as. I should create that like this probably. Some empty dictionary. Doesn't make a difference. Okay, what's the problem now? What's the problem now? Stop iteration? What? Doesn't even tell me what the problem is. So what if we don't apply this, but we print control nodes. Not so sure though. So first of all, print edge, print like this, then print node. So we're iterating over the nodes, and then print the control nodes. So for Q0, there's node 121 and 122. Where is 122? Is this thing again having dirty stuff inside? Yeah, probably. That's just empty, whatever. Then node 127. And 130. They're both control now. Yeah, they're both the controls. So I should say print end of edge, right? End of edge. End of edge. So we have, it's the problem, we have two nodes as controls. It's not 136 and 139. Why? When they're both, they're definitely not. Oh. Q0, end of edge. 136, end of edge. 139. Why is this 139 if node qubit equals Q0? What if we don't print any of these? And we don't print these. So we have Q. Why? Okay, so what the heck? I don't want the edges. Edge 144. I don't want edge 144. Why is it? Why are you returning me? Oh, sorry. Get entanglement edges, definitely. System. There we go. There we go. Okay, so now just two edges. Yeah. Okay, so now it should work. So. So for edge 160, 171, there is, you know, just one node, which is 172, which is a control node. Exactly, and then 175 is the control node. Okay, makes sense. Perfect. Perfect. So this is, yeah. So now if we apply if we apply these, what will happen? I don't know. I'm gonna stop here. Okay. It's still breaking. Why is it breaking? Target nodes. Why is it breaking? Target nodes. Target nodes are empty. That's not good. That's not good. It's not possible. Edge. That's not possible. No, so for edge 210, 212 and 211 are 29, 29. What is these? Edge 207, has these two nodes. Edge 210. It just has okay, 209 and 211. But why end of edge? I think I'm doing this in the wrong place. Oh God! It was in the correct place before. That's what it should do. There you go. No, what's the problem now? Node 217. What is the problem with node 217? What is the problem with node 217? Key error. That this node doesn't exist. What if we just apply these once? What if we just apply these once? Get entanglement edges. Uh, mm, can I break in Python? Still doesn't work. Okay, so it's something's going on here as I apply the 2-qubit gate. So I'll have to debug these, but it's you get the point, right? So I'm trying to say, okay, so given just I'm trying to operate within every branch, right? Because that's what you want to do when you have branches. You want to operate it within each branch separately. Because if not, the whole system is a branch, right? Yeah, probably. Exactly. Like that's the usual case. So you just give it the elements across the whole system, and here you need to go through each edge and then apply the control gate within each edge, so to say, each computational branch. And then this will lead to a case where we have to actually do some merging, I believe. And then we'll just think about this merging. So, okay, it was not what I was expecting to do, but I mean, I think that's definitely an important step forward as well. See you next video.